A quite interesting question related to the hydrocarbons is a hydrocarbon X is found to have a molecular mass of 80 and the 10 grams of that particular hydrocarbon is subjected for the hydrogenation. As a result of that hydrogenation, the amount of hydrogen consumed is calibrated and its value is indirectly provided as 8.4 ml of hydrogen gas is consumed under the conditions of standard temperature and the pressure. From this you can know the weight and the number of moles. Here also number of moles information is provided. On doing ozonolysis of that particular hydrocarbon which is claimed as X over here, it yields the different varieties of carbonyl compounds. One in them is formaldehyde and other is dialdehyde. A aldehyde which is having two carbonyls in it. Then you are asked to write the possible structure of the given hydrocarbon and the formed total number of fragments present in the hydrocarbon are expected from us with the given information of the details. If I write the graphical, that is not graphical, structural, it is not at all known as structural, that is equation behalf of the given presentation related to the question can be the given information. If I write CXHY is my hydrocarbon, whereas this is claimed as X, it is allowed to react with the hydrogen. As a result, it is forming saturated hydrocarbon. 10 mg was taken and the gram molecular weight is found to be 80. N1 versus N2, if I want to calculate the how many moles of hydrogen is consumed with respect to the 1 mole of hydrocarbon, N1 is found to be weighed upon gram molecular weight, that is 10 into 10 power minus 3 divided by 80, whereas this N2 will becomes equal to, from the ideal gas equation, that is PV is equal to nRT relation, whereas this N will becomes equal to PV by RT, pressure is found to be 1 atmosphere, volume is 8.4 ml, that is 8.4 by 1000 by 0.0821 into what? Temperature, that is STP temperature implies 273, whereas this is 1000, this is also 1000, getting cancelled. If I make N1 is 1, then how many times of N2 is there? So this will becomes equal to 1 by 8, whereas this will becomes equal to 8.4 divided by this is 22.4. Whereas if I make this N1 as 1, if this is 1 time, this 8.4 into 8 divided by 22.4, then this particular value reaches near as, so it reaches as 8 ones, that is 8 twos are 16, 8 eights are 2.8, 2.8 into 3, that is 8.4, so therefore it reaches in the ratio of 1:3. 1:3 stands for what? Here the number of double bonds, the amount of hydrogen consumed is 3 times to that of the amount of substance present implies there are 3 double bonds. There are 3 double bonds are present. It indicates presence of 3 double bonds. How many double bonds are there? 3 double bonds are present. A 3 double bond containing system is further subjected for the ozonolysis. That ozonolysis related information with the confirmed idea of having 3 double bonds is this particular compound on ozonolysis followed by zinc, that is reductive ozonolysis, it is producing formaldehyde. Formaldehyde everybody knows, that is formaldehyde implies this particular structure. It is possible if one carbon, that is terminal double bond, is present in the structure followed by a dialdehyde formation occurs. Dialdehyde formation occurs. This is dialdehyde. Dialdehyde implies aldehyde in which 2 aldehyde groups are present is said to be dialdehyde implies. This is a structure in which at one side terminal double bond is present, at other side is also terminal double bond is present. Due to this cleavage, it results into the formation of formaldehyde. Whereas dialdehyde, to occur dialdehyde, yes, from here one aldehyde occurs, from here one aldehyde occurs, but it is having only 2 double bonds. To get 3 double bonds, we are expecting a structure like this. In this case, if cleavage occurs, this results into the formation of dialdehyde. It says formaldehyde followed by dialdehyde formation occurs implies only one variety of aldehyde, that is dialdehyde is single variety implies there is some symmetry. This particular portion and this particular portion remains the same. Hence, with the given information of having molecular weight 80, with the given information of having molecular weight 80 followed by it is having three double bonds. So we can write a nearby tentative structure. The nearby tentative structure appears as, with a relative rough idea also we can go for this particular logic. Suppose if I feel it is a normal saturated hydrocarbon, it is an extension of CH2 for n number of times. CH2 stands for, the general weight is what, 14. So it is having 3 double bonds, implies 3 double bonds stands for nearby another 6. So therefore 86 divided by 14. So it results as approximately nearby 6. So there are 6 carbon atoms. Out of 6 carbon atoms, I have to write one at the terminal, another at the terminal. I have to write a double bond in the middle. It has to maintain symmetry, so there won't be any kind of other substitutions. If this is my structure, if I write in zigzag format, it appears nice. So therefore, this might be the structure. So in zigzag format, it appears good. So therefore, this is, no, I will write once again. In zigzag format, if I write, so therefore 1, 2, 3, 4 and 5 and 6. This particular leads to the formation of formaldehyde. This particular cleavage also leads to the formation of formaldehyde, whereas this particular one gives dialdehyde. Here also symmetrical dialdehyde, here also symmetrical same dialdehyde formation takes place. This dialdehyde consisting of 2 carbons. This dialdehyde is consisting of 2 carbons, 2 plus 2, 4. 4 plus 1, 5 plus 1, 6. It matches with the molecular weight of 80. Hence the total number of fragments, we can get one fragment from here, one fragment from here, one fragment from here, another one fragment from here. Out of these 4 fragments obtained from this molecule, 1 and 4 are same and 2 and 3 are same. Like this, if this is the structure, then it can match with the given idea of having 3 double bonds followed by producing formaldehyde followed by dialdehyde with the molecular weight of 80 and the given information.